Morning everyone, welcome back to the channel. In this video, we will discuss how to optimize the Docker images. Before going to start the session, for those who haven't subscribed my channel, can you please subscribe my channel? So in this video, we will focus more on how do you optimize Docker images, how do you decrease the Docker image size, and how do you remove the unnecessary files or file system from the Docker image. Okay, so before get started, you already know every organization has started doing container based deployment, which is called modern way of deployment. So they are not doing the traditional way of deployments, where in the traditional way of deployment, we need to build our application in separate server, and we need to take the application output, then we can copy it to the server where and all required, then we can configure it, and then we can start the application. Finally, we need to monitor that application as well. So instead of doing like taking the application, copying to the servers, configure it, then start it, we simply create the containers, which is called as a modern way of deployment using the container. So this is where how do you create the containers? Okay, so to create a container, basically we need a Docker image. So from where we can create the Docker image? So first foremost, we need to write the Docker file by using the couple of Docker instructions like from instruction, work directory, user, run, env, expose, cmd, entry point. So based on our requirement, we need to take the instructions and we need to write the Docker file. From that Docker file, we can use Docker build command. We can create the Docker image. Then we can, once the image got created, we need to push that image to the Docker registry. Then finally, we can create the container by using the Docker registry. So this is how we can create the container. So basically, we need the Docker image which contains everything that is needed for deploying and run our application. So that is where Docker image is more of read-only system, which contains all the things that we need. Okay, so by saying this, what is actually having in the Docker image? Docker image is made up of different layers of files or file systems or folders or dependencies. So suppose example, if you want to build our Docker image of Java application, so related to the Java, what and all the different dependencies, different files, different artifacts are needed, we can keep all those and we can create as a image. So image contains multiple layers of the files actually. Now what is that layers contains exactly? Okay, so the layers contains fundamental building blocks which contains of different files. Okay, different file systems like binaries, libraries, scripts, and other dependencies that we need to run our application. So that is where the important ingredients for your Docker image are layers. Okay, so suppose example, if we can create one directory using run instruction, that is called one layer. If we can give the permission for one folder or file, that is also one of the layer. So if we can run multiple instructions, automatically multiple layers will be created. Okay, so that is where what are the different types of layers in the Docker? Typically, there are three types of layers in the Docker image. They are, we can use base image layer and dependencies layer, and we can see the application layer. So these are the three important layers. It consists of Docker image. So now see what are these base image layer and what is the dependency layer, what is the application layer, we'll see. The base image layer consists of platform, which is called OS. The platform is very necessary to running our application. If we need to run any application, the first foremost thing is platform is needed. That platform is consist of base image. So here, what is mean by platform? the OS and what are the supporting libraries for that OS are needed, that we can call it as a platform. And then you put your application on another layer, okay, whether it could be a jar or var or node based application, C++, Python application, Go application, whatever the application you are building, that application you need to put into the in another layer. And then between your base image and application layer, you would have keep all the dependencies to support or run your application. All of these files or scripts we need to put into the dependencies. Example, if you want to run your Java application, you need that Java related dependencies, other binaries, other libraries, all those things you need to put into the dependencies layer. In real time, if I take a Docker image and if I keep adding more and more layers, this is where when your image become more size. Okay, now what are the concerns that we have? Image has more size. If you take any application, we will be doing a lot of changes for our applications to run better way. So in that case, if you add more files and more layers into the Docker image, the size of the Docker image becomes very huge. Now, what are the problems that we have if the Docker image size is huge? Not only the size, but the number of files or layers what you have inside of the Docker image. If it is too much and if these are not actually needed, then that is where by having those unwanted files, your image become a more vulnerabilities. So if it is more vulnerabilities, you have to spend more time and you need to fix those vulnerabilities, and you need to run more testing is needed for those images. So that is where more layers causes more security issues. So whatever the files or layers is not required, we need to remove those. Otherwise, we can get the more vulnerabilities. At the same time, what happened, not only that vulnerabilities, once you created the Docker image as part of that build pipeline, you need to push or upload the images to the Docker registry. Okay, so here the time that you take to build the Docker image will also be increased. At the same time, so if we push that image to the registry, that time will be taken huge time actually. So if you can build that image, your CI pipeline will be also taking more time. After building that, if you need to push that image to the Docker registry, it will take more time. So here, and these are the problem statements what I am discussing actually. The first problem statement is it will get more vulnerabilities, and second thing is it will take more time, and even build pipeline will be very slow. So these are the couple of problem statements. And not only that, when you are going to create a container, which is what we can call it as a deployment, it will happen into that Kubernetes cluster or any ECS cluster anywhere. Okay, so that is where, suppose say example, if you take production, we need to, we need applications or container has started in the, within 1 minute actually. That means less than 1 minute. Okay, so that is when keeping our Docker images less size or lightweighted, then only we can pull that image less time and we can start that application into the less time. So if the size of the Docker image is less, at the same time, we have less vulnerabilities in the Docker image. Okay, so if we have less vulnerabilities and if we can remove that unnecessary layers, files, what we call it as a optimizing the Docker image. Okay, so if the size of the Docker image is less, at the same time, it is less vulnerabilities and removing the unnecessary files, layers, unwanted layers. So all this process we can call it as a optimizing the Docker image. And that's exactly what we are going to learn and see in this video. Okay, so here are the problem statements we have seen actually. If we cannot optimize the Docker image, so the size getting huge unnecessary files, libraries, binaries, dependencies are there. And if we see that unnecessary files or libraries, there are more vulnerabilities. So that causing that security issue, we need to spend more time to fix that, and we need to do the testing. And apart from that, so there are, while doing that CI build to build that Docker image, it's taking more time. And if we can do the pull and push, it will take more time. Even the deployment also will take more time. But in production, so we are expecting the application should be started in the less than a minute. So if the Docker size is more, we cannot start the application in the production is the less time. So even the build process is also very slow. So to consider this, we have a couple of methods where we are going to optimize the Docker, and we can remove the vulnerabilities. We can remove the time for build time, push and pull time, and even we can remove the deployment time. So here, based on this problem statement, so there are a couple of ways and methods are available to optimize the Docker image. So from there, we are frequently used 2 or 3 methods. So we'll see what are those. So the first method is use minimal base image. Okay. So the second method is multi-stage build. So let's see what is that minimal base image. Example, Alpine image. Okay. So slotted images. There are different images are there. Then what is the multi-stage build? What is the multi-stage Dockerfile? Then after that, as we discussed, minimize the number of layers, or we need to explore the image layers. So we no need to keep n number of layers in the Dockerfile. If we can keep, the Dockerfile size will be increased. Then the next thing is we need to remove the unnecessary files or directory. And we can see that before creating the Docker image, we need to write that some instructions. So we need to optimize what are the instructions are needed creating the Docker file for particular application. And apart from that, we need to manage that dependency management as well. We no need to put a lot of dependencies. Example, we need to download file from the remote repository. We need to take that output from some other build mission. We need to take some other dependencies from other mission. We no need to keep all those things. Just we need to use that volumes optimization. Then from there only we need to pick up easily without depending on the host mission. We need to maintain the network configurations as well. And while installing the packages, we need to save the space. We need to install the package runtime. Once that application or image is created, we need to delete it to save the space. Then we need to do for the cache. And so we need to maintain that .docker ignore file, which and all not necessary after runtime. We need to use the Docker build cache. Then copy only the files is needed. That means unwanted files we need to remove, and enable the memory limitations and CPU limitations. Okay. And the next thing is splash the image layers and utilize the Docker volumes for the data persistence. And finally, we can do for a regular scan images for the vulnerabilities. So these are the ways or methods are available in the Docker image optimizations. Okay. So in the next video, I will be discussing about so what is the minimal base image is needed, and I will give that practical session using couple of Docker files. We can create that Docker images with minimal and with huge base images, and we can see the difference. Then we can see the multi-build stage pipelines. Okay, so all those things we will cover in the next video. I will do the series of videos for this optimization of Docker images. I will share those videos as well. Thanks for watching.